Okay, so in this problem, this is a projectile motion problem. And the idea is this. You have a plane. Let me see if I can draw a little thing going on. So I have an object that's going to be dropped from a plane down to an island down here. There's my island. All right. And the idea is that the velocity of the plane is only the horizontal piece to it, the horizontal velocity. So anytime you deal with projectile motion, you want to keep everything separate. Vertical and horizontal always needs to be separate here. You don't ever want to mix the two. Vertical has nothing to do with horizontal. Horizontal has nothing to do with vertical. Okay, but you want to list your givens as always, but just make sure they're separate. So the first thing we can right away put is acceleration. We know vertically the acceleration is negative 9.8. And I don't know what I just wrote there, so I'll clean it up a little bit. So I got negative 9.8. And horizontally, the acceleration is always 0. There's never acceleration going on in the horizontal. What else we got? Final position is a good one. This is going to fall 1,000 meters. Okay, so we can put that here. 1,000 meters is going to be right there. We are trying to figure out horizontally. Here's my question mark. We're trying to figure out how far it's actually going to travel. So horizontally, XF is what we're looking for, question mark. All right, what else do we need? Well, initial velocity. My initial velocity, 100 meters per second, is a horizontal number. And in this problem, it's purely a horizontal velocity. It will start speeding up vertically, but right now there is no initial velocity vertically, so that is 0. All right, and the last thing is time. And time is the only thing that is in common between the two sides, because however long it takes for an object to fall is also the time it took to go that way, because it's the same object. So that's the only thing they have in common, which means what you always want to do is solve for time on one side and then use that information to get your answer on the other side. So we're going to figure out time first, and I have only one unknown on the vertical, so that'd be a lot easier to solve for this time. Then use that number to solve for XF. Okay? So here we go. Vertically, and you want to keep all your numbers separate. So vertically, what do we got? Well, it's going to be this equation. Right there. I can cross some stuff out. My initial position is 0. Unless I ask for or give you initial position, 0. My initial velocity vertically is 0. That's 0. That's gone. So all I have left is XF equals 1/2 AT squared. All right. I can do a little bit of algebra. Multiply both sides by 2. Divide both sides by A. So far I have T squared is equal to 2XF over A. I square root both sides. I have T is equal to the square root of 2XF over A. All right, I can plug in those numbers now. So that's going to be equal to the square root of 2 times 1,000 divided by negative 9.8. Now, that's going to give us a problem, right? Because I have a square root of a negative number. That doesn't make sense. But really, it fell down 1,000 meters. So that means that is a negative number as well. If gravity pulls down and we make gravity negative because it's pulling down, the downward distance of 1,000 meters is also negative. So those negatives will cancel out. Okay, and I do square root. So let's plug it in. Square root of, second square root, 2 times 1,000 divided by 9.8 because the negatives canceled out. And I get 14.3 seconds. All right, so that was all vertical. Now we have to go to horizontal. All right, so horizontal. So we don't want to mix the two. Never put in vertical numbers for horizontal and vice versa. So horizontal, I have XF equals XI plus VI times T plus 1/2 AT squared. again. But in this case, my horizontal acceleration is 0. So that is gone. Don't put in 9.8 there. Okay? Initial position, again, is always 0, really. So all we have is xf equals vi times t. My initial velocity was 100, and my t, we just figured out, was 14.3. So we get 1,430 as my final answer in meters.